Can I build a functional rocket with onboard camera, computer and parachute under just $100? This is Project Who. The first step was planning what exactly I want to build and what it would take. I wanted to build a functional rocket about 60 to 70 centimeters tall. It needed an onboard computer, a camera and a safe parachute landing. All fully 3D printed because that's one of the goals, to make a 3D printed rocket fly without using carbon fiber, fiberglass or any good material for rockets. So let's get started. How do rockets actually fly? Everybody knows rockets use fire to lift off, but how is fire able to make a thrust to lift something? I mean, a usual campfire has about the same energy as these small rocket motors, but your sausages don't fly, usually. The problem is a campfire releases energy in all directions, while a rocket motor forces it through one nozzle. And if the motor is releasing pressure one way, the rocket needs to go the other way. So basically I will use gas from collected farms. I'm kidding. I will use this thing called a modular rocket motor. It uses solid chemicals that burn together and then release pressure with fire in just one direction. Yeah, hopefully. So for my rocket I wanted to use 3 of these motors, but then I realized it would cost me over 45 euros just for motors. So I needed an alternative. And I came across this thing. It's also a rocket motor, but it has 4 nozzles instead of 1. It was produced in Czechoslovakia for military flares, called ROS 40, and it's probably over 30 years old. But I got one piece for only 2 euros, so I bought 25 of them. And while I was waiting for my motors, I made a 3D model of rocket booster on the computer. The booster is basically the part of the rocket where the motors are, so it creates thrust to get the rocket into the air. And because these new motors have a little bit less power than those I wanted first, we will use 4 of them instead of just 3. When the motors finally arrived, I still had some problems. Do you remember how I told you the motors have 4 nozzles instead of 1? This has 1 main nozzle and 3 angled for rotation. Flares use this to fly straight without fans. And that's smart for flares, but I definitely don't want my rocket spinning like crazy. And unfortunately, when they were designing it, they didn't think that 30 years later some random guy would try to build a rocket from it. So I got a really good idea to block them with 3 screws. And yeah, my house is still standing. But now I needed to test if it still works, because to be honest, I kind of knew it would explode. So I went outside to try 2 motors like this. The first exploded. And so did the second. So I drilled a 4mm hole in the middle to increase the diameter of the nozzle, which is another really good idea. And this time only one exploded. But the second bulged from overpressure and it wasn't far from it. So I decided to test 4 different nozzle diameters. 5mm, 4.8mm, 4.5mm and normal with rotation, which wasn't a very good idea. So I set up my improvised setup for calculating the power from numbers on the kitchen scale. And I got results only from 4.8 and 5mm diameter. The 2 others flew out of the stand and 4.5mm almost hit me. But anyway, when I tried to read the numbers on the display, I realized the scale didn't catch it right. So it all sucked and I have nothing again. But I will use the 4.8 motor because it's the smallest that didn't explode. So now, after we know how the rocket will take off, we can continue to the next step, which is rocket body design. The whole rocket is separated into 3 main parts. First is the booster, where, like I said, all the motors are. Next is the main body of the rocket, where the flight computer is, which I will talk about later, and also a parachute between the booster and main body. And last is the camera section with the nose cone. And in this camera section there is space for a GoPro Hero 5 session. I picked this GoPro because it has good video quality and is small, so I can easily put it in the rocket and secure it with this mechanism that works simply with a screw. And the whole rocket except the booster is held together by a threaded rod. I 3D printed all plastic parts from ABS filament because it's light and strong, and then put it all together. And at this point this actually started to feel like a rocket. But like I said earlier, we need to record all the flight data to an SD card. So how do we do this? I basically used a few sensors that will give us information about altitude, speed, acceleration and some other things. But these sensors alone can't write anything to an SD card, so I used a microcontroller Arduino. Arduino is basically a small device you can program to repeat one loop of tasks. And with the help of my new computer science team, my loop is programmed to read all the sensors 10 times per second and then write all the data to the SD card. It looks simple, right? No, I'm just kidding, it actually wasn't that hard. After I connected all the cables and the device was finally working, I still needed to somehow put it inside the rocket, so the components wouldn't just float around and disconnect due to spin and vibration. So I made this plastic stand where I can mount all the electronics. And after I put it all together, I must say it looks really cool. Something like a bomb, but not a bomb. Anyway, when I finally solved all the problems, I also added two LEDs that will tell me if the rocket is ready to start and if everything runs correctly. Then I tried to put it inside the rocket and everything fit. Perfect. At this point, almost everything worked individually, but I had never tested it all together. But the final task is to actually land it without breaking the electronics and the body. And for that, we'll use a parachute between the booster and main body. And this is actually really important, because if it won't work, the rocket will hit the ground going over 100 km per hour. After 5 seconds the motors burn out, this thing at the end of all 4 motors will burn and that will activate a small charge that separates the booster from the main body. And then a parachute attached to the main body will deploy. I made this parachute from an old umbrella and attached some strings to it. And surprisingly, this worked really well and actually looked like a parachute. But the charge was a little bit complicated. It basically has 4 fuses that will burn when the tip of the motor does after burnout, and this will set it off. It needs to be strong enough to separate the rocket, but not too strong so it won't damage it. But the problem is I actually can't test it, because the charge will be activated by the motors, and if I fire the motors just to test separation, I will damage the booster from heat and would have to 3D print another one. The booster isn't reusable, and after burnout it will fall freely without a parachute. So I tried to figure out the optimum power of the charge and I think I got it. But this could potentially be a problem later, so hopefully I got the power right. Now you know all about the rocket, how it was built, what motors it uses and how the flight computer works. But how much did it actually cost? Was it under the $100 limit? But before that, there is actually one really important thing to do. Every successful rocket needs paint. So because this is Project Hoo-Hoo, don't ask me why, I just call everything Hoo-Hoo, I painted just these 4 letters to let the 3D printed layers stick out. Definitely not because I'm lazy and I didn't want to paint the whole thing. Anyway, really. How much did it really cost? The filament for 3D printing was 15 euros. All motors, including tests, and the 4 that the rocket will fly with were 20 euros. Flight computer, including all sensors and the Arduino, was 25 euros. And GoPro Hero 5 was just 26 euros because I got it secondhand for a good price. The parachute from an old umbrella was free, and the pyrotechnics to separate the booster from the rocket were also free because I already had it. So everything together was 86 euros, which is exactly $100.8. Like literally $0.8 over budget. Hopefully that won't ruin me. Yeah, of course, it took me almost a month of my free time just to build it, but it's really fun to make projects like this. And I would do it again. And I actually will. In the next video I will fire this thing up and also show you some final things about the launch. Like a remotely controlled launcher for this rocket. On paper this rocket should fly and then safely come back. But if not, it will either explode in the air or go back without parachute over 100 km per hour. But it will be fun, for sure. If you hit subscribe and like if you liked it, it will really help this channel and I will be able to build even crazier and better things like this. Thank you for watching and see you next time.